Hi everyone, my name is Ross Bagurtis and welcome to my course, Introduction to Enterprise Network Infrastructure. I'm a network engineer with more than 20 years experience building enterprise networks and teaching people about them. Data networks use specialized hardware to move data from one point to another. Most of this hardware is designed to achieve a very specific task. And in this course, we'll examine the data networking hardware required to accomplish this, including wireless access points, cabling, routers, and switches, as well as other devices. By the end of this course, you'll understand the purpose of different types of network cables, Ethernet operation, how routers move packets, and what a load balancer is and why we need it. Before watching this course, you should understand the concepts presented in the Network Concepts and Protocols course. And after completing this second course in a 5-part series, you should feel confident moving on to the third course of this series, Network Management and Operations. I hope you'll join me on this journey to learn networking with the Introduction to Enterprise Network Infrastructure course at Pluralsight. Welcome to Pluralsight. I'm Ross Bagurtis. This course is Introduction to Enterprise Network Infrastructure for the
Kind of
CompTIA
strange because
2010-008 exam. This first module,
according to our system, it accepted you in.
Did it? I can't remember.
So maybe it's got to do something with the door problem.
That's unusual.
Yeah, it's green. It says it accepted you in.
Yeah, I told him the doors and did his play.
Hmm.
So it might be the. Oh, man.
They'll let you.
That would suck. Yeah, you can follow. Have a good one, man.
we're going to talk about physical layer technologies. Our goals for this module are first to do a review of the OSI model so we understand where the physical layer is in relation to the other layers. Next, we're going to talk about physical layer medium options. Now, the medium here is going to be the stuff we use in order to send our signal. So we're going to talk about 2 of the 3 options we have at the physical layer. We're going to talk about copper cabling and the specifications for it, and then fiber optics and the specifications for that, including lasers. Then we're going to talk about Ethernet designations and how we call out the different types of layer 2 or data link layer Ethernet, and how they need to use very specific types of cabling in order to achieve the speeds required. So let's get on with talking about the physical layer here. Now, in the previous course, we talked about the OSI model, and I gave you a general idea of what happens at each layer. Now, as we progress through this course, we're going to talk more about physical layer stuff, data link layer stuff, and network layer stuff. So we're going to focus mainly on the bottom 3 layers of the OSI model, and let's start with the physical layer here. So the physical layer, we can have one of 3 different options in order to move data. One of those is copper cabling. Now, it doesn't necessarily have to be made of copper. Really, the idea here is that it's going to be made of metal, but most of the cabling we use in most situations is going to be copper. Some friends of mine have hacked around with using some technology to actually move Ethernet over train tracks, but that's a pretty unusual circumstance. So we're going to stick with just copper cabling here. The second option we have is fiber optics. Fiber optics is going to be a very thin strand of glass that we use a laser to shoot a type of light through. So it's actually photons that are carrying the messages that we're trying to send over our data network. The last option, which we're going to save for another module in this course, is wireless. And wireless is also going to make use of photons in the electromagnetic spectrum. And in this case, we're not going to have an actual physical thing that we use to send the signal. With wireless, we use an antenna, and we're going to use the electromagnetic fields to send a signal. So we're still using stuff. It's just not stuff in the way that humans are used to seeing it, like we can recognize a copper cable or fiber optics. So we'll talk more about wireless in another module. Let's start with copper cabling. Copper cabling can be divided really into two different categories here that we use in data networks. The most popular and most common that you will see, the one that you've likely seen in your home or in your office, is twisted pair cabling. You can see the factory over on the right here where they're putting together some twisted pair cabling. You see all the spools of copper wire, and they're going to twist those all together and put insulation around it in order to make those cables. The second type of cable that we can use in networking is coaxial cabling. You may even have seen this too in your home if you have a cable modem, and there's actually some types of coax that we can use in data centers as well. Let's start by talking about twisted pair cabling. Now, the reason that we use twisted pair cabling in data networks is to help increase the amount of data we can push through a wire. Now, there's a phenomenon, a physics phenomenon, that if you have a wire and you pass an electric current through it, that will create a moving magnetic field around the wire. And also, in the same way, if you pass a magnetic field over a wire, Now, in the previous course, we talked about the OSI model, and I gave you a general idea of what happens at each layer. Now, as we progress through this course, we're going to talk. Let's start with copper cabling. Copper cabling can be divided really into two different categories here that we use in data networks. The most popular and most common that you will see, the one that you've likely seen in your home or in your office, is twisted pair cabling. You can see the factory over on the right here where they're putting together some twisted pair cabling. You see all the spools of copper wire, and they're going to twist those all together and put insulation around it in order to make those cables. The second type of cable that we can use in networking is coaxial cabling. You may even have seen this too in your home if you have a cable modem, and there's actually some types of coax that we can use in data centers as well. Let's start by talking about twisted pair cabling. Now, the reason that we use twisted pair cabling in data networks is to help increase the amount of data we can push through a wire. Now, there's a phenomenon, a physics phenomenon, that if you have a wire and you pass an electric current through it, that will create a moving magnetic field around the wire. And also, in the same way, if you pass a magnetic field over a wire, you will generate an electric current in the wire. That's how generators work. That's how we produce electricity. So the problem in data networking is if you have two wires right next to each other and you put a current through one of them, the signal in the one wire will jump to the other wire very easily. We solve this problem in data networking by using twisted pair cables. And if you twist the wires together at very precise twisting rates, you can prevent that crosstalk, which is that signal jumping from one wire to another. So if you look at this image, you can see that the pairs of wires that are twisted together in both the top and bottom images on the right there, you can see they're twisted together at different rates. You can see that the blue and white one is twisted together much more tightly than the brown and white one. And same thing with the green and the orange. They're all twisted together at different rates. By doing this, we create a cable that can pass lots of data at high rates of speed with minimal crosstalk and interference from other things. Now, all these twisted pair cables are put into different categories. The categories have different specifications to allow for different types of Ethernet communication or different speeds of Ethernet communication. So we start here with Category 1 cable. Now, Category 1 cable is doorbell wire. It may not even be twisted. It's really not even networking cable. It's only worth talking about in the sense that it is Category 1 cabling and is part of the system of cables for twisted pair. Second cable type we have here is Category 3. Now, Category 3 cabling was used extensively for telephone systems, and these telephone systems eventually became repurposed for some use in Ethernet. So we can run 10 megabit Ethernet over Category 3 twisted pair cable. This was real convenient back in the late 90s when data networks were just becoming popular. Most office workers did not have a computer at their desk in the mid to late 90s. As a matter of fact, you had to be in a very special office setting oftentimes in order to have a computer at your desk, and when you did, it was usually using 10 megabit per second Ethernet. And usually, in fact quite likely, you didn't even have internet at your desk in the late 90s. At the time, 10 megabit Ethernet was just fine in order to achieve what was necessary for file sharing or maybe email in those days. But as time evolved, we needed faster data networks to move bigger files. In that case, we came up with Category 5 cabling, which just had tighter specifications on the wire itself, and it allowed to pass traffic at 100 megabits per second using Ethernet. Shortly after that, we came out with Category 5E. Category 5E is difficult to distinguish from Category 5, but the idea here is that we increased the specifications in the manufacturing process to make sure those twists were twisted together at very precise rates. Everything about the cable was made in a more precise way in order to get those higher speeds. The same thing happened with Category 6 here. We increased the specifications and also added this little plastic spacer in the middle of the wire. And that plastic spacer, what it does is it keeps those 4 pairs of wires very well separated in the exact way that's necessary in order to pass traffic at a faster rate. This eventually led us then to Category 6A and Category 7 cabling, which allows us to pass 10 gigabit Ethernet over it, so 10 times as fast as we can get with Category 6. The idea here, again, is that we're just using more precise specifications when we're making the cable in order to achieve those higher data rates. Now, there's another thing we can add to each of these categories of cables, and that is shielding. So up on the top image there, we see unshielded twisted pair, or UTP. This is likely what you're going to see most often in the real world. We're going to just have a cable and you're going to cut it open in order to put an end on it or attach it to a patch panel, and there's going to be no metal shielding around it. However, if we're in an environment with lots of electromagnetic interference or radio frequency interference, meaning we run these cables past fluorescent lights, or they might run past a very strong radio transmitter, we don't want those signals from the lights or the radio transmitter to accidentally corrupt the signal that's traveling through the wire, which can easily happen. So what we can do in the cases where we need it is we can use shielded twisted pair, or STP, and the shielded twisted pair here helps prevent a lot of interference from external sources of electromagnetic interference. Which brings me to Category 8 cabling, which I didn't put on my list here because Category 8 cabling is special. It has other restrictions on it that the other cables don't have. It can't necessarily go the same distance, and it has